In the last video, we saw that we can set up a class that's going to be used as a base class and have it work with instances of derived classes that may be written maybe years in the future, but still everything works. So that's the real power of virtual functions. And when we write C++ programs, we just assume that it happens by magic. That is, it just works. We don't worry about how exactly it works, but the explanation is pretty simple. It just involves late binding. So this idea that we've talked about earlier, that is, virtual functions implement late binding. The compiler says, wait until the function is used in a program to decide which method or which member function to use. It's based on the calling object. So let's just take a quick look at the code. Remember, here was our example where we set up a sale object and a discount sale object. There, discount sale is a subclass or a derived class of the sale class. And you can mix and match. So you can say, you can use discount class, an instance of the discount sale class on the left-hand side of the relational operator, which is overloaded in the sale class. So you don't have to overload it for the discount class. So what does that mean? So let's remember that you're saying discount less than simple. Discount is an instance of the discount sale class. Simple is an instance of the sale class. So let's take a quick look at that. Here's our sale class, and here is the less than operator overloaded for a left-hand side, which is a sale object, and a right-hand side, which is also a sale object. If you take a look at the discount sale class, you'll see that there is no redefinition of the less than operator. You can use the less than operator that's defined already for the sale class. Okay. So what's so great about this? Well, notice that you're using on the left hand side a discount sale object, on the right hand side a sale. And you can still use the less than operator. Why? Because that's polymorphism. Okay, so at runtime, you decide which less than operator to use. This is like saying discount dot operator less than, and then in brackets simple. If you look in discount sale, there is no less than operator. You can look in the discount sale CPP class as well. Look in here, there is no less than operator. The compiler decides at runtime to use this operator, and it says the first is actually a sale object, and still everything works. That's the amazing thing. Okay, so our nice simple compare method, less than method, less than operator can compare sale objects, two sale objects, one discount sale and one sale, two discount sale objects, or two sale objects, so on. Okay, and same thing with the dot savings method. The dot savings method was defined in sale.h to work with just a sale object on the as passed in as a parameter or argument. And notice in discount sale.cpp, discount sale.h, you don't have to redefine the savings member function. You can if you want to, but it'll work. It'll work with discount sale objects just because of inheritance, just because of the fact that discount sale inherits from sale. This savings member function will still work. Okay, so let's go back to the notes. So how does virtual work? It works by using late binding. This is a very important object-oriented programming principle. Okay, so remember, overriding is just a redefinition of something that's in a base class. So the virtual function definition is changed in a derived class. We say that it has been overridden. The base class member function is overridden. This is similar to sort of redefining for standard functions. So when virtual functions are changed, we refer to this as overriding. When non-virtual functions are changed, we say that this is redefined. So if you have two classes that are related by inheritance and you don't use virtual functions, then we use what we're really doing is redefining what that member function is supposed to do. Okay, then you might ask, well, since Java uses all virtual functions, and actually that's true in Java, all member functions are virtual, why don't we just use all virtual for all member functions? There are many clear advantages, as we've seen in the last few videos, clear advantages to using virtual functions as opposed to non-virtual functions. The only major disadvantage is there's a little bit of time overhead and a little bit of storage. So if you use virtual functions, your virtual table, which we talk about much later, it becomes a tiny bit bigger. Also, late binding is on the fly, so programs will run a tiny bit slower because you have to go into the virtual table and figure out exactly which class in this inheritance scheme this member function should come from. And so you might have to follow pointers up and down this class hierarchy and decide on which member function to actually use. This all happens at runtime. It's a lot of checking, but it's not that huge. It won't slow your program to a crawl unless you're using virtual member functions in a loop, in a tight loop. Yeah, that kind of thing can potentially happen. So yeah, there is the disadvantage of speed. It's a little slower. However, that's almost always outweighed by all of the advantages we get from using virtual functions. So the book does say if you don't need to use virtual functions, don't use them. Your program will just be guaranteed to be faster, but I'd say in general, most people will, the efficiency is not that big a deal. Okay, one last thing that we want to look at as far as different options. You can have pure virtual functions. That is, the base class might not have any meaningful definition for some of its members. So for example, the figure class. The figure class is supposed to be abstract. There's nothing to draw, really. And so you can make this draw member function of the figure class be a pure virtual function. And the way to do that, in Java, all we did was we said abstract, void, draw, open close parentheses, semicolon. In C++, the same thing. You can make this, you should make it a virtual member function if you want to make it an abstract class. So the abstract method, sorry. So first of all, there's two components. One is you set it equal to 0 to make it an abstract member function. Plus, you make it virtual, and you have to make it virtual if you're going to make it an abstract member function. Okay, so this is called a pure virtual member function, as opposed to a virtual member function that has a method body, which is still virtual, but it's not pure virtual. That is, it's not abstract. Okay. In Java, the difference is you never need to say virtual, and in Java, we don't use the equal 0. We just put the semicolon, and that already means that it's equal to 0. That is abstract. In Java, you have to explicitly, in some situations, you have to explicitly say abstract in this modifier section. Okay, so once again, we use this for cases where the classes will never be instantiated, that don't have any meaningful definition for some of its member functions. And it's the whole class is there. The purpose of those classes is solely for derived classes to where everything will be defined properly. So the figure class is the superclass or the base class for rectangles, circles, triangles, etc. The figure class by itself has nothing to draw. These derived classes have things to draw, and the draw member function is defined there. Okay.